Bismillahirrahmanirrahim. Sudah siap?
Siap.
Kamera cek.
Recordnya jangan lupa. Langsung aja.
Recording in progress.
Partisipannya tampil. Partisipannya. Selamat pagi, Bapak dan Ibu sekalian. Boleh dibuka dulu untuk ke apa? Mute-nya.
Silakan.
Selamat pagi, Pak.
Selamat pagi, Pak Sunarko. Terima kasih udah join dan udah ada Ron ya, Pak Adi ya.
Pagi, Pak.
Pagi Pak Fatlan, Bu
Selamat
Cici.
pagi Mas Arizal.
Wah siap.
Sehat selalu Mas Aris, tetap segar mukanya.
Pagi Bu Cici dan semuanya, selamat pagi. Mungkin kita tunggu beberapa saat lagi ya sambil menunggu yang lainnya untuk bergabung di webinar ini, karena masih ada beberapa yang sedang join ke sini.
Good morning, Igrim. Good morning, Takut.
Morning,
Morning.
Igrim and then Mr. Takbert.
Good
Good morning
morning.
to everyone.
Good morning.
Good morning. Good morning. Welcome to the webinar.
Ya, sambil nunggu kita 5 menit lagi ya untuk kita mulai acaranya, sambil menunggu yang lain untuk join di webinar kali ini. Dan sambil menunggu juga boleh untuk mengisi absennya terlebih dahulu untuk bisa nanti dapat sertifikat webinar. Dan senyum yang manis dari Igrim. Boleh. Sambil nunggu kita video dulu ya, yang tadi mungkin ada yang baru belum lihat, kita tampilkan. Jam 10.05. Selamat pagi Bapak dan Ibu sekalian. Assalamualaikum warahmatullahi wabarakatuh. Ya, sebelum kita memulai acara webinar kali ini, ada baiknya kita berdoa dulu. Untuk itu berdoa dimulai. I agree we can first pray first for the success webinar.
Okay, thank you. So, Tuberk, please share the presentation before I start. Thank you. So, good morning, everyone.
No, oke, terima kasih
Excuse me, Alison.
untuk doanya. Dan boleh untuk di awal kita akan foto sesi, karena kan di sekarang nih masih pada seger-seger ya mukanya nih, masih pada ganteng-ganteng dan cantik-cantik. Boleh kita foto sesi dulu Bapak dan Ibu sekalian, untuk diaktifkan videonya. Oke, kita mulai. Ada beberapa yang belum untuk diaktifkan videonya. Mohon Bapak dan Ibu untuk diaktifkan sejenak. Kita foto sesi sebentar aja. Pak Fadlan, Pak April, Pak Fadlan, Pak Yuli, boleh diaktifkan Pak? Pak Asanjaya, Pak Dedi, Pak Adi, Bu Cici, Pak Adi, Bu Cici boleh, Pak Jeffrey,
Mas Adi malu-malu nih Mas Adi.
Tahu aja.
Oh siap.
Jangan malu-malu Mas
Pak Dedi
ya.
apa? Oke.
Lagi kucel banyak ini gawean ini.
Ya udah, oke kita mulai. Posenya yang ganteng ya Bapak dan Ibu sekalian. 1, 2, 3. Sekali lagi 1, 2, 3. Oke, terima kasih Bapak dan Ibu sekalian. Dan selanjutnya saya akan memperkenalkan terlebih dahulu. Nama saya Arizal Matadinata yang ada di flyer, dan mohon maaf sekali untuk saat ini di webinar kali ini Mbak Mentari sedang menjalani isoman, dan semoga Mbak Mentari di next webinar bisa bergabung kembali dengan kita dan semoga lekas pulih kembali. Dan sebagai penggantinya kita akan dibawakan langsung oleh Mr. Takbert. Dan sebelumnya kami perkenalkan dulu, di sisi lain ada Miss Aigrim. Hello Aigrim. And then behind side-nya Mr. Takbert. Oke, untuk memulai acaranya mungkin baiknya pertama kita akan tampilkan dari Aigrim. So Aigrim, we can time is yours. You can present.
Okay, thank you, Rizal. And sorry for starting the presentation way earlier. I'm just excited to see everyone here.
Yeah.
And thank you to connecting. Welcome to our webinar. So please have our greetings from Turkey. And today I'm going to do some brief introduction about our mining solutions. So Tuberk, can you please share our presentation on the screen?
Okay.
All right, thank you. So before we start giving some information about mining solution, I want just to give you some brief info about our company. So NetCat is a leader software developer company in Turkey, and we have 30 years of experience in developing engineering softwares here in Turkey. And we can say that we are leader of the market here in Turkey. And right now, we want to share our experience in developing some technologies abroad as well. And our most important region for us right now is the Southeast Asia. And thankfully, we are partners with Mir's team, and we are now working on developing some business over there. So NetKit, can we go back right now? Thank you. Okay, so NetKit is working under the motto of smart solution for smart minds. So we are not only developing some desktop solution, but also working on developing some web-based solution, IoT platform solution, and some smart solutions as well. So our, let's say, the biggest aim is to make our lives more comfortable. So we can skip to the next slide. Thank you. So as I told you before, NETPROMine is the leader of the Turkey market, and as the developer of CAD and GIS software solution, 85% of Turkey's spatial data was produced on NetKit solution. So right now we have 600 licenses of our mining software all over the world. So totally we have 1,000 of users. We have users here in Turkey, majorly in Turkey, but in addition, we do also have some users from Canada, from Brazil, from Central Asia countries like Kazakhstan, Uzbekistan, Azerbaijan, etc. And plus here in company, we have about 200 engineers. Some of them are software developers, some of them are mining engineer, geology engineer, survey engineer, etc. So our company is based on in Ankara city. The headquarters is in Ankara, but also we have region office in Istanbul. So everyone who are going to visit Turkey, we are always welcomed by NetKit team here. So we can skip another slide as well. So as you see, we have a different scope of the solutions. So NetMine is the name we are given for our all mining solutions. So here, the webinar topic is our desktop solution, NETPROMine. Besides desktop project design solution, we do also have some IoT-based solution, web-based solution, and also smart camera and smart sensors involve smart solutions as well. So we are just want to give that give this idea that NetKit is not working only on the desktop part, but also trying to make some intelligent mining as well. So we can skip for the next slide as well. Okay, so here I want to talk about our key benefits of the program. So we have developed our software in order to increase the productivity and efficiency of the mine workers, of the engineers, of the mine area. So also it helps us to perform mine operations quickly and easily. And all the projects designed on NETPROMine will be always up to date, as we have some dynamic update tools. So after doing doing any revisions on the program, you can quickly update the whole project. So also we have some strong editor tools, which helps you to edit your project in order not to make some mistake in the further step of the project. We do also have some tools to save the different version of the program. So you can save the project before revision, and after finishing the second version, you can compare them and define the most suitable for you. So we know that most of the mine specialists use several softwares in their work. So our software is compatible with other softwares, so you can easily integrate different types of formats so you can import and export any type of data. So I think the most important and differentiate part of our software is that our users can use CAD and GIS technologies simultaneously. We do also have 24/7 technical support, and technical support in Indonesia gives our dearest friend Mir's team. And yet, I think the last but not least important thing is we offer to our users easy to use interface and cost effectiveness. We can skip to another slide, please. So after this, I am going to give some word to my colleague Tuberg, and he is going to give you information about our NETPROMine solution. NETPROMine is 3D desktop solution, which helps you to use integrated tools like resource estimation, geological modeling, open pit and underground design, and also open pit optimization. So in the scope of our topic, Tuberg is going to give you some technical details about geological modeling, and plus our brand new tool, implicit modeling. So go on, Tuberg.
Thank you, Aygerin. But I would like to say a few things also. So this is our, let me share my screen first for the NETPROMine site. Okay, I think everybody can see it. Yeah, today actually our colleague Riri, we heard that she was sick. Today we are going to continue to process that I know she talked about geological modeling and the other steps. She introduced NETPROMine. We will continue from her work as well. So at the today we are going to talk about the resource estimation. And in the resource estimation part, we are mostly going to work on the block modeling as well. To start, I would like to remind you that we need borehole data for starting. After the borehole data, we need a geological model. What we have underground, exactly how it looks. There's two ways of making a geological model. One of them is creating a sections and getting a geological model by sections. And the other method is our brand new method, is implicit modeling. So in this part, I would like to talk about the sectioning part. So according to the sections that we have, because we are getting a section from the top side of the boreholes, and then we are turning that into geological model by combining them. So if I uncheck the boreholes, you will see that our section model totally produced by combining the sections. There are a few things that you can do in the geological model part as well. So as you can see, there are some triangles on the solid model. Because I opened the area borders to show you that we are creating a triangle model while we are combining these sections. And the other thing is you can also see the drilling data or valuable layers inside the boreholes. Sometimes it may not be easy like this data, because I know this is only a chrome data that we have in the red part that you see, but it can also be combined in the whole borehole or drilling data. So in that case, there will be different solid models, of course. That's why we was working on implicit modeling. We will talk about implicit modeling features after I explain the resource estimation. But now we are able to do a lot of geological model designs, and you can get a lot of results in a short time. So to continue our session, I would like to produce a block model from that geological model, because sorry, because it's a geological model and it represents the potential ore body underground. So we can't exactly estimate what's in there. As you might all know, there are some different values inside the boreholes. For example, the tenor content might be in this borehole 20%, or in this borehole it can go up to 30%, or in the middle of it, it can be a 10%. So we have different variables, and we need to assign those values to see what kind of material that we have. It, of course, depends on every mine. For example, in a coal mine, it would be a calorie. The quality of the coal you will have, that kind of information you will get from the drilling data. To see those informations, we need to make a block model. We are dividing the geological model as much as possible to assign some values into that block models. To do that, I will show you how to do a block model. So simply, you can right-click the solid model that you have, and you can select the blocking part. After, when you have the blocking part, it will ask you the block sizes and how many blocks it's going to be. To make that easier, you can simply measure before you are doing a block model or creating a block model, because the whole length of this model is, if I'm not mistaken, already 200 meters or something. So I can't divide it into 50 meter blocks. So that's why I'm choosing 5 meters for X and Y sides, and for the Z, for the elevation, I'm dividing into 4. So the blocks that we are going to create is going to be 5 meters for X and Y sizes, and 4 meters for the Z side. There is another criteria for creating a block model. There is a sub-block criteria. The sub-block criteria helps you to get closer to the geological model as much as possible, because in the geological model, we are going to create 5 by 4 sizes block models, but near to the edge, we are going to produce the sub-blocks more. Smaller blocks will cover geological model and represent the geological model even better. Let me show you with an example. So at first, I'm not using any sub-block criteria. By the way, okay, I can't delete those blocks. Do not confuse you. I would like to delete it, but never mind. The first, I'm going to create a block model without using any sub-block criteria. And this, the other thing is that I would like to also explain block acceptance percent. Near to the edge, your blocks, some part of the blocks will be empty. And this is the factor that affects block modeling too much. The criteria, the number that we gave, means that near block, if near block includes 30% inside the block, if we have a 30% geological model, we are going to produce the block. If it's not, we are not going to produce block for the edge, for the limit area. So first, I'm creating a block model without using any sub-block criteria. Okay. blocks that I created all in the same sizes, as you can see. And we represent the solid model. I will open the solid model again. Solid model all inside the block model. The second thing, I'm going to produce a block model by using a sub-block criteria. Okay. It may take a little bit more than the other process because we are creating a lot of blocks by using the sub-block criteria. And as you can see, the model is now become much more detailed than the other one. We can see it visually, but what is the results if you would like to learn? So I'm going to open the first one and I will check its properties. In the properties, it says to us, your solid model was 316,000 meter cubic, and your block model volume is 300,000. So we represent 95% of the geological model in here. And it also shows us how many blocks we used, 3,000 blocks, and the block sizes. So it's a 95%. It's quite acceptable, but not close enough. I would like to show you the other block model. And this, by using the sub-blocks, we were able to get 97.26% of representation. It has 307 or 308, we can say, thousand of volume of blocks. And we can also see how many blocks we used. So just for the sub-blocks, we created 11,000 more blocks to represent this geological model even better. I will delete the other blocks. Okay, now what I would like to do is I would like to make a copy of it. I created 2 more copies. This copy function also so useful for the blocks that you are working on. I will talk about it later. So in the block model, we have the block model now. By the right click, we can check the object properties and we can see the block, any block's properties. So this is a sub-block that I get. I understand it from the X, Y, and Z sizes. And I have some coordinates for this block and total volume of this block. So what I would like to do, I would like to assign my sample values to that block model. Because in the boreholes, we had some drilling information. So we have lithology records in some parts, we have chrome lithology, and then according to these information, we do also have a tenor attribute, or calorie attribute, or any other attribute for different type of mines. It can be any type of attribute. So first, we need to do a composite process. Now we are going to turn that raw sample value into sample values. So the composite name, first I'm entering the length and acceptance percent. Length, how many pieces that I'm going to divide that lithology, because I'm using lithology to model this geology in that time. So I will divide this lithology into small pieces, and it's going to be a 1 meter. You can always decide length information by using the length and attributes properties of the boreholes. You can check it from here, for example, the length, attributes, all groups. So you will get variance, standard deviation, and some other statistics. If you would like to export, you just check the sign, and when you close the screen, you will get a notepad that shows you the numbers. You can use that numbers in somewhere else too. So also acceptance percent. So we are dividing the lithology into small pieces to accept those little pieces. How we are going to decide if we have less than 1 meter. It also what it means. So let's say if it's a 25 centimeter, accept this lithology. If it's less than 25 centimeter, don't accept this lithology. So this is what acceptance percentage mean. I'm selecting the attributes. We might have a multiple attributes in here, no problem. Or we can use the lithology filter. We can make the composite process by using just the lithology feature as well. As a borehole group, I'm selecting the all boreholes. In the ungroup section, I have all the boreholes. So I'm going to use all the boreholes. After that, after this operation, now we are going to, I'm checking the properties of the borehole at the moment. And in that part, now we have sample records divided into 1 meter pieces. Before this operation, we didn't have any sample records, but now we produce the sample records. So let me also show you how it looks. We can make a display of composite results in 2D and 3D. So 10 meters. So it's showing me in which part, in which tenor value we have for this sample. So in that part we have 10.07, 11, 21, but this one is more understandable. So we have 2 different lithology, 2 different tenor values. So we divided that information into pieces. Then we can also make a display in a 3D based. Now we can see the legend of the tenor is divided into 4 pieces. We can also edit that part. So thematic editing I'm going to do at the moment. I don't want to see the 4 pieces only. I would like to see I'm creating a numeric range. I'm selecting the tenor information. And then I'm dividing into 7 equal pieces, thematizing with the colors that I want. Sorry. Now I can see the tenor information and in which part I have more valuable material in it from the top side if I check it. So in this part, for example, the tenor value in between 19 and 24%. And in this part, 29 to 34. Also, even if they are the same color, they have different diameter. So you can see that it's both green, but this one is closer to the 14. This is the thematic view of the sample information as well. So you can also check from this display in which part of the boreholes you have much more valuable material. Okay, next thing is resource estimation methods. So the first method is before doing the estimation, just to remind you, you need composite information always. Other than that, it's not going to work with just the raw sample. You need the composite information. So in the estimation methods, today I'm going to talk about these three methods, which base methods and highly used. But the nearest neighbor, I will start first. The nearest neighbor method works like taking the information from the closest borehole. If the blocks, for example, closest to one borehole, it will get information from that borehole and that lithology. And the other blocks will get from the closest borehole, get the information from the closest borehole as well. So with that, the logic behind it, which boreholes are close to the block and which information it can get. This is how it works for the nearest neighbor method. This is quite simple method, I would like to say. So again, we get information from the nearest blocks, and we have 4 divided pieces. Automatically we find it, we produce it. So I would like to make all of the blocks in the same thematic range, so we can compare them later on. Minimum value will be 0, 35, and 5. So 7 pieces again for this estimation. Okay, now we can see the blocks also get the tenor information. If I right click, sorry about it, not the grid. If I right click and select object properties, and click a random block, I can see its tenor information. So for example, the first one was the 20 tenor, and the second one that I choose 11.21, and it goes and goes. Okay, the second method, now I'm going to talk. Also, if you would like to see just only, for example, blocks that higher than 10%, you can simply remove the other layers, uncheck the other layers, and you can see the parts or the blocks that have higher than 15, 20% of attributes. The second method is I'm doing it to another block, the same block. Properties of this block is the same, but it's empty, no values assigned yet. The copy of the same block. So the second method is inverse distance method. In the inverse distance method, what we do is we are creating an ellipsoid, and this ellipsoid gets information from around the boreholes and also from the blocks that already assigned. So to make it more clear, I would like to show you the ellipsoid at first. Close the borehole. So now I'm going to create an ellipsoid layer name. I'm typing at the moment. Ellipsoid. Color of the ellipsoid will be blue. I'm choosing the center of the geological model, or the block model, we can say. In here we have ellipsoid parameters, the x-axis, y-axis, and z-axis. We need to enter these values. And then I'll just make these settings to 0 so we can start it from scratch. I'm giving some transparency to the block so we can see ellipsoid more clear. Then I'm arranging my ellipsoid for assigning or getting information from the around the blocks. From the Z side I made, from the X side I'm checking. So the rake information is also valuable for me, something like that. And deep information. Okay, so my ellipsoid will visit each block now and will assign values to the nearest blocks with the iteration. It will visit each block's center and it will get information from the blocks and also from the boreholes. When I'm satisfied with the ellipsoid, or when I'm satisfied with the ellipsoid directions, I can synchronize settings here. In this method, we do have ellipsoid settings. So when I click synchronize settings, as you can see now, it's azimuth is 125, dip is 25. It will change the numbers and synchronize the ellipsoid settings to here. Now I can complete the estimation process by clicking OK. I close the ellipsoid and the thematic process. I'm also doing the same operation for that blocks, dividing the information into 7 pieces. So now we assign different values to the different blocks, and we can see the transition between the blocks more clear. So some sort of a line in here, a little bit has more than 15% tenor, and the lighter ones. So we can see the transition even better. For example, in here we have the lowest ratio, 5% tenor value, but behind it we do also have some blocks at the same time started to become valuable, blue ones and the purple ones, because those are in between 30%, 30–35%. This method is commonly used in the resource estimation. The other method is creating a variogram map, and then kriging to the block. Now I open another block, which is empty, we can call it, doesn't have any attribute information. Again, from the variogram, I will use Variogram Map, which is much more easy to create a Variogram Map. So according to your values, you can automatically calculate. You all have to do is deciding the bandwidth for the model, and then apply the results. In the variogram model, we would like to make a variogram map for this geological model, and then we will get the variogram graph. We turn the variogram values into semi-variogram values. The purpose of using this map is actually finding the anisotropy direction and using it to get a variogram graph. And then we will decide some other information. So as you can see, the longest edge or diameter, I can say, we can see it in the 60 direction. The other directions are, some of them are empty. The longest direction is 60 to 240. So by using that 60-degree angle, that will be my anisotropy direction. And I'm going to click the calculate, and I will see my variogram graph at the moment. This one. Okay. So in here, we are deciding the seal value. But to decide a seal value, we need to get the point that it starts to change its direction first. We get this point, but the graph, some points of the graph are all outside of our polygon. So we need to arrange the range as well. Let's select 32, yeah. So this is our range, and this is our seal value. There is also a nugget effect. For the nugget effect, we decide to take the we wanted to get the ending point of this. If it continues, where it's going to start. So combining starting point of the polygon and the point. So something like that I take as a negative effect. And I clicked OK. So In this part, the important thing is getting the information from the variogram graph, which geologists using this variogram maps and making a kriging information most commonly. Now we are adding a kriging. The parameter name, it says it's a kriging name. It will be, and we are choosing the attribute value. In the variogram part, I will delete the structure. We will select our variogram structure. So it's a 60-degree that we created. And I'm selecting its structure. So when I bring the structure here, we get the ranges and angle information. Also, sill value. Turning back to the parameters, we have ellipsoid parameters, which we can also get a copy, get a information from our inverse distance method. We can use the same ellipsoid parameters in here because it was okay for this geological model. So the ellipsoid process is also same. That's why I didn't show you again. To show ellipsoid, we can arrange the azimuth or deep angle, etc. So I'm clicking OK. Now we have kriging information. Now I can use, by right-clicking the block model, estimation, and I can do the kriging estimation. All I have to do to choose the kriging, I select the K1 kriging, and variogram data and the parameters that I'm going to use is ready. When I click OK, okay, it's doing the estimation for us. There are also some blocks which are couldn't be decided exactly. That's why it makes shows us as a minus, but it's not valuable or on the edge really. So in this time I will do the same thematic range, but I have to use also minus values. So I'm arranging this thematic range as a -5 to 35 this time. So it will be 8 different pieces. Okay. Now it's also quite similar in the inverse distance. We got here 15% tenor layer. Also the blue one now is 50. So we have a 50% tenor value layer in here. And let's check the valuable part. So inside the valuable part, also well distributed. Start from the high and getting lower. Some blue blocks we have here. Okay. So after the distributions, actually, why we are doing it? We are doing it to get the block information, which blocks we have underground, and what to expect from those blocks. I will check another object property of some random block in here. I can also see the tenor value of this block. We can assign as much as attribute that we have to the block model without any problem. And there is also another thing which I would like to show you. So if you have more than one attribute, not like this. So for example, we have a tenor information and you can select the blocks that higher tenor information than 10%. If I apply the filter, I will just get the blocks that has higher tenor value than 10%. So in here, what we can add, if you have information like calcium or iron content or magnesium, other information, you can add all the filters and use at the same time. So in this sample, we have one attribute, but I would like to also show you what we can use as a filter in here. So at first, I would like to show you the area filter as well. I'm just throwing an area. And inside boundary filter, I'm also going to use. There's no value, filter criteria. All points of the blocks must be inside this area. When I click apply filter, it asks me choose the area. So when I select the area, it is filtering for me. So this is my block model after I filtered. Or I can use another criteria, like the Z value, for example. So 400 elevation, almost we have here. You can check the Z information on the screen as well. I will filter until 420, let's say. Center of block points, block center Z value higher than 420. Apply filter. It will ask me to select the area again because we are using all of them. Now, as you can see, we cut the block model by using the Z filter as well. And if you would like to use this block, because this is a block model that filtered, you can get a copy of it. If you get a copy, you'll just get a copy of this filtered block. And then you can remove filter conditions from this block. And turn back to frame number 1. So you didn't touch this block, you also get a copy of a filtered block. So the results, by getting the results, you can simply get a block report at first. By deciding the tenor information, we didn't add density information, but we can use something like 2.7 I'm using as a density information. I click OK. So for the filtered block, in between 10 to 15%, we have 60,000 volume. And the other part, we have 6,000 volume. Total volume, and according to the density, how much mass, how many pounds we can expect from it. And the average grade. Let's see the other block. Not the first one, the second one. I would like to check its block report as well. So in total, we have 290,000 volume, and the average grade is around 10%, and a total tonnage. And average grade for every thematic range that we select. You can also edit the thematic range, and you can get results according to that ranges. There is also one more thing, which is quite important, block list report. So I'm going to go to my data, Chrome data, for example, block report. I'm saving it. I don't take the density information. Again, block list report. So now I have a block report as a CSV file. I would like to show you this results. So every block has an information on this Excel, block sizes and the ratio of the block. If you remember, we select the ratio at 30%. We didn't produce any block if it's less than 30%. This is that actually showing for every block how many percent they're including the solid model, and the tenor information for all blocks. By using this 6 information, the block coordinates and XYZ sizes, you can import and export that block model to any software, or you can also get block models from other software as well. All we need is that coordinates and the block sizes. It shows the completions of NETPROMine with other softwares as well. Everybody or every software have that kind of output. That's 6 information we can use. So that was the resource estimation part. There's also another report, maybe we can also talk about it, grade, tonnage and curve report. It's also giving us the tonnage and curve according to the grade. Average grade in between those ranges, and tonnage information. So filtering is possible according to the all attributes. Whatever attribute you have, you can filter your block model after producing it. And we also talk about the estimation methods, how you are going to assign values to each block. Each block becomes unique and different after doing the estimation process. So we can understand what kind of material we have, what to expect. We can check the block model results. So also, I would like to talk about implicit modeling now, because we recently released. I didn't talk about it before. It's actually a geological model part. So you are seeing the implicit model at the moment, and there's also a section model in here. So the section model we were creating from the sections, but to make these sections, we were getting those sections one by one. So what is the section that includes those lithologies? What is the section for the second part? And by doing this handmade Sometimes it's taking a lot of time, and also because of the human mistake, it might be incorrect. Now, with the implicit model feature, we offer users a lot of things, basically. On the geological modeling part, you can also do a couple of things. So, for example, now I'm going to talk about the geological model tools. In here, we have geological model tools. That's orange tabs on my screen is all of them. We are using all of them for implicit model operations. There is also advanced settings, which we might talk about for the advanced users. If you would like to see some results on the screen, you can check the settings, you can close them or keep using it. So the first thing is lithologic modeling. I will make a first implicit model with you together, and then we will check implicit modeling results from the video, because taking a results requires different data types, and it takes it will be too much for this webinar, but I will show what kind of results we can get by using the implicit modeling. Just I will briefly talk about the implicit model features at the moment. So if you have a lithology, like in this data, you can simply select the lithology and you can create a geological model by using this lithology. The minimum and waste and ore thickness that we have in here is, if you have a little lithological pieces, you can decide either taking this lithology into account or not. Also, same with the waste thickness. If you would like to combine those lithologies, or if you have two small piece, and if you would like to combine those lithologies except as a one whole lithology, you can select the waste thickness, like I don't know, maybe ½ meter, and it will combine the lithologies and accept as a one whole lithology. The next thing is grid. So the X, Y, Z ranges, you can also think if it's like a block modeling. We have a grid, as you can see, but we are producing points inside all the grid. And this point locations, we deciding by using that X, Y, Z ranges. So instead of a whole object, you can think like it's a point cloud. We are producing lots of points inside that grid. And you can arrange extra direction. For example, it's a little bit limited, so I will give 10 meters more extra direction for my grid. Okay, now I include this part as well. Or you can select the grid boundary. The other features we will also talk in the video. So this is my point settings. This is my grid. I'm clicking just OK. Now we produce some points for these boreholes. Now I'm going to remove the boreholes. As you can see, we actually define the lithology by the points, by using just points. So the points that has minus feature is our lithologies, and the positive points are not in the lithology. The next thing we are going to do now, we are going to assign values to all grid square. So in the grid, we do also have a lot of points now, And by using that lithology information, we will assign points to whole grid, and we will get final RBF points. RBF is the name of the method, radial basis function. By using radial basis functions, we are assigning values to the grid points. So this is a place setting. In here, it's creating you the points, the RBF points. This is the function. You just click the play button and it does the RBF function for you. And now we can see, if I remove the distance points, now we are seeing the potential geological model. The next part, the shell model part, how we are going to produce a shell model. So simply you can produce your first shell model by applying this. It's a little bit bulky, as you can see. I will give some transparency to that model. Now I'm going to produce the blue one, blue geological model, and I will increase the model detail a little bit. So the model will be much more closer to the boreholes. So this is the second model. As you can see, the boundary of the first model and the second model. It's much more closer to the boreholes. For a third model, let's make a red one. We increase the model detail a little bit more. It might even separate some parts. Okay, now we have 3 different models now. The first model, the bulky one, the second model, and the third model. It needs some evaluation as well. User need to evaluate this information a little bit. Then you can find the most appropriate model for you. So I will move forward to the videos to show you what kind of results you can get with NETPROMine implicit modeling now. So this is actually starting with the geological model, I think. Yes, talk about it. Just give some parts. Okay, as I said, we can produce different geological models in a really short time. And the part now that we would like to show you is some RBF points are separated, and we can consider that points as isolated points. So in a little bit less in the video, we have also little solid model piece for those points, but we can also isolate that points by deciding distance between them and how many number of points are far away from the main RBF points. So we isolate it, and next time we produce a block model, next time we produce a geological model, we are not going to get that isolated points, as you can see. Or we can remove some solid model pieces by drawing an area. And produce this geological model again. Now we are not going to take those pieces as well. We will produce a model like that. Now there is an object method. If you have other objects, you can also remove this part from your solid model as well. You can simply draw an object, solid model of it, and then it takes that part from your implicit model as well. The other thing, we can extend some part to that plane. So we arrange plane directions and we arrange plane distance. Then we extend the model to that to the plane. We are drawing a section. From this section, we are going to extend this model to the plane. We can also select how we would like to extend. In here, amount of curl, that part. We can also extend by selecting that information too. And if we have a few points that we would like to add to the model, or little point cloud, we can also consider this layer, and we can add this layer to solid model as well. The next part is local trend. If you have boreholes in the different areas, and if they that boreholes have a different patterns for each of the area, you might have separate boreholes and different layers, different pattern, and simply you can use the local trend, and the software is going to solve this situation for you. You're selecting different local trend areas, and it's accepting that those boreholes having a similar pattern, and it creates RBF points by considering that. These are the local trend points, and then after producing the local trend points, we are creating a RBF points. And then we can create a solid model for all of the RBF points. The next thing is grade modeling. which is quite useful. Besides from the lithological modeling, we do also have a grade modeling. And like I said, you can add a couple of attributes. It's similar to our block model filtering system, but according to the attributes that you have, you can create your own geological model from the beginning. Like a 15% tenor value. You remember the geological model from the session that I showed you before, but it will produce geological model directly higher than 15% tenor value. It created the RBF points. And then the geological model. Also, there are some advanced settings for the implicit modeling. Like I told you, this setting section. If you would like to see the distance function points or resulting model point, RBF points, and some other features, you can use this advanced setting window. And you can see the results. I was using it, and so we together we see that distance points and how we produced. It takes the lithology and the minus points. RBF points as well. You may see it or you may not see it according to your advanced settings. You can keep the distance settings, and by the transparency you can also see the layer points as well by the distance points. So this is what I would like to show you, everyone, today. And I can get a few questions about implicit modeling or resource estimation if you have. We can make a quick Q&A session. After that, my friend Arizal will explain our demo program as well. So if you have questions, quick questions I can take about implicit modeling or resource estimation part especially. Resources classification. So by classification, what we would like to do in that part. If you can extend the range a little bit, I can explain if we can do it or not.
Hi, Takwa.
Hi.
Yeah, so there are some questions. So just let me summarize it for you. Hold on. Number one is about whether it can be used for mineral as well as coal. Already answered that can be done both mineral and ore, right? Secondly, that is a standard question for everybody. That whatever that the software is so, it is so what do you call it? So precise, yeah, compared to the actual results. So the question is about how many the standard deviation from the calculation of the resource as well as the reserve, yeah, using this NETPROMine software compared to the result. So I think this is the question that everybody asks, and the answer is I know that it depends on the data, right? If the data is good, and I think the result is also good. But what we can answer about this, I think, is that how precise that the software calculate the data. So maybe you can answer this as a question number 2. And number 3, that is asking about Al-Zikid regarding the trial. Already mentioned that we have the program that export, as well as the consists of the NETPROMine store and ore that our result will explain later. And we also providing the trial for 2 weeks or 1 month, depends on the request for the prospect. Yeah. And the fourth question is getting the scheduling. So whether this is software has the scheduling, already answer that the scheduling we do have it for the long-term one, as well the resource estimation, the mining reserve, as well as optimization, design and design, as well as the survey. But maybe you can add more about regarding the scheduling. So there are 4 questions for the resource classification. So totally there are 5. Please, Dr. you can answer it by
Okay. So this software, like I said, it can be used for both minerals or coal or different mining fields, because the attribute entrance we are doing it here. Like I said, this attribute for the Chrome information, I had the data, and in that data, I had the tenor information, the percentage of the Chrome content inside the lithology. That was my data, and I kind of know my data and how to evaluate that data. If it's a coal mine, for example, you can get the results from the laboratory, and it would be a calorie quality or some sort of mineral content inside the carbon content, whatever attribute you would like to add to the software, you can actually add it. And by filtering options, you can filter all the attributes, and you can get the results. The second thing is, yes, it's, of course, if your data is good, your results are much more better and more accurate. We do also have some cross-validation, but also all the softwares require some experience from the users as well. You also need to evaluate the situation. So you might get different solid model, for example, but if it's not you want it, you need to change the, like I said, in the implicit modeling, for example, you can change the detail, or you think that it has to be some another solid model, or it doesn't have to be. You can remove it, you can take it back. Some other features we have. We have tools, features for all modeling operations now. With the implicit modeling, actually, we offer users lots of things now. So yes, it's data also depends the results a lot. If you have good information, the results will be really good. About the NETPROMine Explorer program, the demo part, my colleague Ariza will explain it after me. And so scheduling. The other thing was scheduling. Right now, we are able to make a long-term optimization. So according to the years, you can see your pushbacks, you can see your production and other stuff. But by the scheduling, we are also going to add the shift. So it will be a different story. Right now, we just released the implicit model, and now we focused on the scheduling, and it will be added to the software. Hopefully in this year, I can say. But we focused, and now we are working on it. It's just a reminder that, so it will be also released, and we will have a scheduling part as well.
Oke, thank you, Takbur. Maybe Bapak-Bapak kalian bila ada mau bertanya langsung, silakan sudah di-unmute mungkin ininya, ya gitu. Silakan, Pak.
Boleh Bapak dan Ibu sekalian, untuk yang ingin bertanya boleh langsung bertanya kepada
Yes, Armand has a question. Dynamic ellipsoid feature, you can use it during the estimation. I also saw that a vein system, so you can also create different seam points, and you can produce another solid model by using the seams or veins, and then you can also create your geological model more accurately. Okay, Arizal, I took your part, sorry.
Oke, no problem. Ada lagi yang ingin bertanya Bapak dan Ibu sekalian?
Maybe the last question, Takbur, regarding the classification. Have you answered it, the question? About the resource estimation classification, which GORC code that you are referring to?
Well, resource classification. I need to also check about it, the resource classification. So, indicated and measured. Just a second. So, standardization. We can get all those information from that, but I need to also check if it's that J or RC code related or not also, but we can get all the information for the resources, if it's defined or not. So that's why I also wanted to extend that information a little bit more, but yeah, I can answer that question. You can send me a mail to, for everyone actually, because we are going to finalize our webinar, but for every question that you have, you can send me. This is my email, and I will answer you. April, if you can send an email, I can answer to your question as well later on. And for everyone, of course, this is my email address. If you have any technical question about the software, you can always send an email to me. I'll be glad to answer. So, okay, I think we finalized it. Our result. Sorry again.
Oke, no problem. Oke, jadi Bapak dan Ibu sekalian, apabila nanti ada yang ingin ditanyakan kembali, bisa langsung email ke Takbert, ada di kolom chat. Dan saat ini kami ingin menawarkan, bisa ditampilkan slide-nya. Ya. Di sini kami ada dua program, Stone dan OR. Di mana OR itu untuk universitas dan STONE itu untuk profesional, untuk corporate. Jadi apa sih isinya OR dan STONE di sini? Kalau untuk yang OR itu adalah selama 12 bulan untuk trial lessonnya, dan untuk yang profesional itu 6 bulan. Kedua-duanya dapat training dan konsultasi, dan bisa apabila nanti Bapak dan Ibu sekalian tertarik untuk mengambil program tersebut, bisa menghubungi saya. Di situ ada alamat email dan nomor WA saya juga, bisa langsung hubungi saya. Jadi kita terbuka untuk program ini, atau Bapak dan Ibu sekalian untuk yang mencoba trial 1 bulan, kita akan buka juga di sini. Jadi bergegaslah untuk mencoba trialnya, karena ini sangat menarik softwarenya.
Bisa aja Mas Arizal.
Kapan lagi kan bisa ke Turki nantinya. Gitu.
Coba kebab ya Mas Arizal ya.
Ya, bisa berbagai macam. Nanti ada Miss Aigrim yang akan mendampingi di Turki. Ada yang mau ditanyakan Bapak dan Ibu sekalian untuk di webinar kali ini? Boleh tentang softwarenya, boleh untuk programnya. Kira-kira ada tambahan atau ada masukan atau seperti apa gitu yang sekiranya bisa kami bantu untuk Bapak dan Ibu sekalian. Boleh diaktifkan mikrofonnya kalau ingin bertanya. Halo Bapak dan Ibu sekalian. Bisa
Mana
diaktifkan.
Pak Zikir, Pak Adi, Pak Ikrar, kalau ada mau ditanyakan lagi mungkin silakan monggo. Pak Sunarko juga.
Mungkin Pak Sunarko, waktu saya ke Tanjung Enim, kita belum bertemu ya Pak Sunarko ya.
Iya Pak, katanya
Ya.
dulu ke PTBA Pak ya?
Betul Pak.
Oh,
Gitu.
iya, saya pas sakit itu Pak, jadi nggak ketemu gitu.
Iya, semoga Pak Sunarko bisa mengambil programnya Pak, yang sudah saya kirim proposalnya tuh ke Bukit Asam.
Oh itu ya, ya udah
Iya,
nanti saya lihat dulu Pak, proposalnya nanti.
Boleh Pak. Ada lagi yang mau ditanyakan terkait produk maupun trial license maupun program untuk STONE atau OR? Kayak kebetulan di webinar kali ini kebanyakan profesional ya.
Ayo Mas Rama, ditanya monggo Mas Rama.
Pak Ikrar boleh kalau ada yang mau ingin tanyakan.
Mungkin nanti Japri sama Mas Yanes nanti. Kalau misalnya demo di kalau misalnya kita mau ajuin demo boleh, bisa.
Oh bisa sekali Pak. Tinggal email ke kami atau WA ke saya untuk di arrange waktunya kapan kita bisa technical meeting untuk di perusahaan.
Oke, nanti Japri sama Mas Yanes aja deh.
Siap.
Baik Pak,
Siap
ditunggu
melayani
Pak.
Pak.
Kita masih nunggu nih, ada pertanyaan nih, kayaknya ini ya
Mungkin pada mikir Mas Aris, jadi aduh ini kok simple amat, gampang amat, mudah amat softwarenya gitu. Mungkin gitu.
Sebelum ini ke webinar ini ditutup, ada mau ditanyakan tidak? Oh iya, dan untuk absen jangan lupa ya Bapak Ibu sekalian, absensinya diisi karena kita akan kirim sertifikat berdasarkan asumsi yang hadir di webinar sekarang.
Sertifikatnya plus kebab nggak Mas Aris? Ini biar enak nih, ada kebabnya, kan? Langsung sertifikat aja.
Lagi PPKM Pak. Mungkin bisa menyusul untuk kebabnya. Atau saat mereka kesini kita datengin, gitu. Oke, kalau gitu kita tutup webinar kali ini, dan terima kasih atas partisipasi dari Bapak dan Ibu sekalian yang telah mengikuti webinar kami kali ini. Dan jangan lupa, kembali lagi protokol kesehatan, kita harus sama-sama melaksanakan program pemerintah juga. Dan yang terakhir, Smart Solution for Smart Mind, NETPROMine. Terima kasih. Terima kasih Bapak Ibu sekalian.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih semua.
Thank you Igrim, thank you Takbert for the
All the information.
Information.
Yeah,
No problem.
Thank you everyone to listening to us. It was really
Ditunggu kabar
really nice to have
baiknya untuk
all of you.
trial, program, dan lainnya. Sukses selalu untuk Bapak dan Ibu sekalian, dan sehat selalu juga untuk Bapak dan Ibu sekalian.
Okay, bye-bye.
Oke, bye-bye.
Waalaikumsalam warahmatullahi wabarakatuh.
Ayo boleh ada yang mau
Sama
ini.
aja deh.
Ini udah selesai nih sesinya, boleh. Boleh tawa TV.
Oke. Bye-bye.
Bye. Udah close aja Pak, stop.
Recording stopped.